So again, there's no bad first guess for diameter. Let's just guess a diameter of 1 foot. That's a really big pipe, by the way. But it's okay. Let's just guess it's this enormous pipe, 1 foot, and see where we go from there. So if I guess a diameter of 1 foot, then what I can do is that I've substituted around the speed. So now I can find a Reynolds number. Right? So we'll say at diameter is equal to 1 foot. My Reynolds number then is going to equal let's see here. Oh, I need density. Let's go look up properties, shall we? I knew there was something I should have done in the last video. Properties. I've got air at 100 degrees Fahrenheit. That'll give me density and viscosity. I need those two values. Okay. So, in our text, we just go to the back of the book. Appendix 2's got English units. Properties of air. So I'm looking, in our text, I'm looking at table 9. I'm looking at table 9E. So in the 3rd edition, that's page 966, table 9E. I've got air, it's been heated to, I'm pretty sure, 100 degrees Fahrenheit. Yeah, 100 degrees Fahrenheit. So I've got air at 100 degrees Fahrenheit. The density here is 0.07088, and the viscosity is over here at 1.281 times 10 to the minus 5. So I'm going to write those down. Density is 0.07088. And I'll get the units in a second. This is, the viscosity is 1.281 times 10 to the minus 5. Density, the units are going to be pound mass per cubic feet. Let's make sure I get the units on the viscosity right. That's going to be pound mass per foot and also per second. Okay. Get this back out of our way. All right. So, Reynolds number. We said just a second ago we're going to use 4 times density. We found to be 0.07088 pound mass per feet cubed. Multiply by volumetric flow rate. Back over here, we said it was given to us in the problem statement, 12 cubic feet per second. Divided by pi. Also divided by viscosity, 1.281 times 10 to the minus 5 pound mass per foot, also per second. And then we're going to guess 1 foot for the diameter. All right. Now, if you're using a fancy calculator, well, I don't know if it's fancy, but if you're using a calculator that's not scientific like mine, where you can do more than one number, you can actually do this pretty quickly in your calculator, because what you want to, all we're going to do from one guess to the next is we're just going to change this value right here, this 1 foot. But that's okay. So here's what we're going to do. We're going to say this is 4 times 0.07088. 4 times 0.07088 times 12 divided by pi and divided by 1.281 e to the minus 5. Now here's what we get here. This is going to be 84,540.7. That's going to be feet divided by my diameter, 1 foot. So for us, this is just going to be 84540, or 8.4 times 10 to the 4. That's turbulence. How do we know that? Well, it's a Reynolds number greater than 4,000. So I've got turbulent flow here. Now we'll see why this is important in a second. Okay? All right. So I've guessed diameter, solved around the speed. That gives me a Reynolds number. Now I've got epsilon over d. That gives me an F value. Right? So Reynolds number of 8.4 times 10 to the 4, and an epsilon over d is equal to 0, because I've got a smooth plastic pipe. That means my friction factor, now I'm going to do this on a chart, and I'm going to do this in a couple of colors here. Come on. All right, we'll do the first one right. So 8.4 times 10 to the 4. So that's going to be somewhere in here, roughly. Now, this is my smooth line. This bottom line here is epsilon over d equal to 0. That's what we call the smooth line. So you take a straight edge, or just kind of as best you can eyeball it, over to where that matches, and I think I've forced that just a little bit, but I think 0.02 is a pretty good guess for first F. Right. So we'll say F is about 0.02 from the Moody diagram. Okay, now you've got these Moody diagrams in your text. You can find them online, as I've done there. Okay, what do we do now? Well, that's what the roadmap's for. I've guessed a diameter, that gave me a Reynolds number, now I've got an F value, now I go back and I can use that F value and the head loss here to find a better value for diameter. So remember, we said head loss is equal to F L over D V squared over 2G. Now, I don't know speed. Now, you could find speed based on this guess of diameter, or we can do some algebra here. We can say, well, this is FL over D. This is, we said earlier, speed is 4V dot divided by pi divided by D squared. And that's going to get squared divided by 2G. This is equal to F L over D. Let's see, if I do this square real quick, that's going to be 16. Right? 4 squared is 16. V dot squared. That's going to be divided by 2G pi squared D to the 4th. Alright, so I squared this. Done some algebra here. So my head loss is going to be F L over D. Now, let's do this. Let's just group it all together. The numerator is going to be, I've got 16 over 2, so it's going to be 8 F L V dot squared over G pi squared D to the 5th. Meaning D is going to be the 5th root of this other stuff. So I'm saying I'm just going to move them over. So it's going to be 8 F L V dot squared over G pi squared head loss. And the good news is since I've derived this once, you wouldn't have to derive it another time. You can use this equation anytime. You can see the algebra there, unless I've made a mistake. And that looks pretty I'm pretty comfortable that's okay. So, diameter is my only unknown here. I know these other quantities. I've got an approximation for F now. So, my better guess for diameter is going to be now the fifth root of 8 times 0.02 times my length. I said back over here was 400 feet. Times my volumetric flow squared, that's 12 cubic feet per second. That's going to get squared. Divided by all these things. Now gravity in English units, of course, is 32.2 feet per second squared. It's going to be divided by pi squared. And we said the head loss, is given to us back over here, cannot exceed 50 feet. Try that there. So, let's do 8 times 0.02 times 400 times 12 squared divided by 32.2 divided by pi squared and divided by 50. And I need the fifth root of that. So let's see, I can do shift this button to the 5. That should give me the fifth root. I'm getting a diameter there of 0.897. Units there should be feet, I think. This is feet to the 6th divided by second squared. The second squared go away. So I've got feet to the 7th divided by feet squared. That's feet to the 5th inside the fifth root. The fifth root of feet to the 5th is feet. That makes sense. Maybe that doesn't make sense. I don't know. It works. All right, are we done? Well, if we were lazy, yes, we could say, yes, we're done. We're not lazy, we're engineers. So, we got to figure out, are we done? Well, what did we do? We guessed the diameter. That we found through that a Reynolds number, which gave us an F value, which gave us a better guess now for the diameter. Did the diameter change between guesses? Well, we guessed at 1 foot, we computed a better guess of diameter to be 0.897 feet. What I would suggest to you is keep going until you start getting the same second or third significant figure. Okay, so I've had a change in at least the first significant figure. So this was not a great guess. It was an okay guess, but it was not a great guess. This is a much better guess. So let's go back through the loop. This is page 6 of today's lecture. Let's go back through the loop with this new value. So at a better guess for diameter now would be this 0.897 feet. That's a better guess for diameter. So, what do we do now? Well, Reynolds number, we said earlier, is this value divided by whatever the diameter is, and the diameter was 1 foot. Well, that's not our diameter now. So the Reynolds number is going to be, if we simplify all these other numbers, 4 times density times V dot divided by pi viscosity, all those simplify down to 84,540.7 feet divided by my new diameter, which was 1 foot. Now my diameter is 0.897 feet. That'll give me a better value for my Reynolds number. So 84,540.7 divided by 0.897. So a better guess at the Reynolds number is going to be 94,248. Okay. So we'll pick up there. So I've got a better guess now for my Reynolds number. Loud pop.